Okay, let's continue with chapter 5, analysis and design of beams for bending. So in this chapter you will learn to construct, to do the analysis of a beam, do analysis of a beam, in which that during the analysis you have to calculate and identify the shear force and also the bending moment. Identify and calculate shear force and bending moment, and also in this analysis you have to draw a diagram which is this is a shear force SF, this is bending moment BM, bending moment. Okay, so you have to, in addition to calculate and analyze the shear force and bending moment, you also have to draw a diagram which is a shear force diagram, which is SFD, and also bending moment diagram, which is BMD, bending moment diagram. Okay, so shear and bending moment diagram. Okay, so the objective of this chapter is to analyze and design the beam. So beam, this is the beam, this is the definition of beam. So this is beam. Beam is a structural members supporting loads at various points along the member. So normally beam, when you have beam and this is pillar or support, so you put things on beam. Let's say you want to build a house, so you put beam. So that beam is actually to support things that you're going to put in your house. Okay, so transverse loading of beams are classified as concentrated load or distributed load. So this is called as transverse load. Okay, so this is transverse load. So the load can be concentrated or distributed. So if the load is only acted here at one point, it is called as concentrated load, like this, like P1 and P2. This is concentrated load. So if the load is distributed like this is called a distributed load. Okay, so in which that from here to here the load is distributed uniformly, or we call it UDL, uniform distribution load, UDL, uniform distribution load. Okay, if applied load result in internal forces consisting of a shear force from the shear stress distribution and a bending couple from the normal stress distribution. So you have to calculate and determine the internal force, which consisting of a shear force. So similar to the previous chapter, you have to in which that you have to determine the internal torque. Here also you have to determine the internal force, the internal shear force. Okay, so normal stress is often the critical design criteria. So this is the maximum shear stress is determined by moment time C, which is the maximum radius, over I. I is moment of inertia. Okay, this is the classification of beam supports. First is simply supported beam. So if the beam is supported at both ends like this and like this, it is called as simply supported beam. So if you move this beam to here, so in which this area is hanging like this, so this area is hanging, we call it overhanging beam. So if the beam is fixed at one end here, at one wall, and then this one is hanging, we call it cantilever beam. Okay, this is a continuous beam in which that you put another support in the middle of two end support, and beam fixed at one end and simply supported at the other end is like this. So this is fixed, and then this is simply supported at another end. This is fixed beam in which that at both end the beams is fixed. Okay, shear determination of maximum normal and shearing stress requires identification of maximum internal shear force and bending couple. So as I said before, you have to determine the internal shear force and also the internal bending couple. Shear force and bending couple at a point are determined by passing a section through the beam and applying an equilibrium analysis on the beam portions on either side of the section. So similar to torsion or any other analysis in forces, you have to determine what is the equilibrium state of forces of forces in y direction or x or in x direction. So the equilibrium state, it must be equal to 0. And then also okay, so this is for shear force. So the summation of all forces, the summation of all shear forces either in x or y direction should equal to 0. And also the summation of all bending moments should also equal to 0, so that you can determine the internal shear force and bending couple. Okay, so this is the sign convention for shear forces. Shear forces is denoted as V here in this chapter, and bending couple is denoted as M, moment. So if you solve the problem from the left, so you will actually shear the beam from the left. So if the directions of the shear comes downward like this, so this is positive. Okay, we put this sign as positive, and the acting moment or the acting couple will go into this direction, and this is a positive directions of the moment. So if you start from the right, you will use this concept in which that this direction is the positive, and also the shear force, the internal forces going upward like this is positive. But typically people will use a left. We will start from the left. Okay, so in order to understand, we look at this example. Actually, what we are talking about. So first, you have to determine the internal. What you want to know in this chapter, what will you learn in this chapter is actually you will have to determine the internal shear force and also the internal bending moment. And then the second, you draw a diagram. You draw diagram. First is for shear forces, and then the second, you draw diagram for bending moment. Okay, so look at this example. For the timber beam and loading shown, draw the shear and bending moment diagrams.